Okay, test. Good afternoon. Am I
Afternoon.
clear? Okay. Okay. Good. So before we start, I'd like to share some information uh, regarding our lab session. There's been a change there. So instead of doing it offline, we have to do it online. Okay? Meaning you don't have to come to the lab and do it online by using all the 5 lab. We'll use multi-sims. So make sure you have multi-sims installed in your PC or laptop. Okay. Let me know if you have problem installing that one, but I think you can find it easily, even the crack one maybe. But if you have problem, let me know. So maybe I can try to find the installer from here, from the lab, and share it with you. Okay, so since it will be can you please turn off your mic first? Okay, let me speak for a while because the echoes is coming out. So since it's gonna be online, so you can have 3 or 4 member in one group. 3 or 4 member in one group. So it's up to you to decide for the member, as long as it's within one kumpulan, one session. Okay. That for the lab, so we have to do it online still. I have uploaded the lab one. Let me share you the lab one. Lab one. This is lab one. If you see here, the equipment component needed. So there's universal power supply, switch phase resistance load, system friends, standard step of patch leads, rectifier ammeter, ampere meter, rectifier fault meter. So inside you learn, you check at the library, okay, check at the library and find this device here. So for example, for figure 1, for figure 1, if you look here, you have 230 volt AC. So find volt power source, voltage power source, AC. Okay, and turn it into 230 and find another resistor. You have 3 resistors here with 2 different value. Okay, so that's it for figure 1. And then figure 2 also still same, simple This one is series. Just now, figure 1 is parallel. Figure 2 is series. Okay. That's all. So measured here. Look at the column here. Measured means the one that measured by the multisims, the value that come up in the multisims. Calculate means the formula, using the formula. Okay. So lab 1, this one is lab 1. So the due date of this one is next Friday. Next Friday, 5 o'clock. Submit the report also online at ULearn.
Sir,
Yes.
sir, is it only lab 1 is in online, or the following labs also in online? All, is it?
So unfortunately, it will be all.
Oh,
And all
only
the
for this,
lab will use multisims.
only for this subject, is it, sir?
Yes. Only for the
Okay.
subject, this electrical technology.
Okay, thank
Will
you,
use
sir.
multisims.
Sir,
Yes. Yes.
remember 3 or 4 people kan?
Yes, for people maximum.
But in the farm page only 3 slot. So
Just add one column more. It's easy, right?
thank you, sir.
Other questions?
The group, sir, are you set or we are choosing by ourselves?
You can choose by yourself.
Okay, sir.
But if there is a conflict, there is a problem, I will form the group. So make sure you don't have any conflict among you of choosing members. Other questions? So if no questions, I will just proceed to the chapter 1. Let me see, chapter 1. Okay. Okay, chapter 1 is on alternating voltage and current. So I try to give you some background of this topic. Alternating voltage is actually AC. AC is actually stands for alternating current, right? Alternating current. So anyone have the idea what is the opposite of AC? Can answer or type in the chat room.
DC current. Direct
DC,
current.
yeah? Okay,
Yes.
direct current, correct. So it's DC, direct current. Okay. Anyone ever heard of Tesla? Tesla.
Yes, sir.
What is it? Tell me.
Scientist.
What?
He's discovered the AC current, alternating current.
Cannot hear you clearly. Can you repeat again your answer? Can you tap the answer? Cannot hear you clearly. Tesla is very famous, especially nowadays. Tesla. Search, if you search in any search engine, if you type Tesla, so the first thing that will come up is a brand. It's a brand of electric car. Right?
Do you mean the Elon Musk car?
Yes, correct. If you search search engine, the first thing that will come up is electric car, Tesla. So actually, Tesla, the CEO, like you mentioned, Elon Musk, is a big fan of this guy named Nikola Tesla. Nikola Tesla. Okay, he was born in Serbian. In Serbian, Serbian is in border with Croatia, Yugoslavia, okay, Slovakia, Serbian, and then he moved to America. Nikola Tesla. So he was the inventor of AC, alternating current. He was the inventor of modern AC. Okay, so nowadays, almost I think in all houses, residents, industries, they all use AC. But back then, during 80s, during 80s, during 1800, okay, where AC is not invented yet by Nikola Tesla, they use DC, like you mentioned just now. They use DC, direct current, that invented by, anyone knows the inventor of a lamp? Lamp. LAMP.
Edison.
Yes,
Alva
Thomas Alva
Alva.
Edison. Okay, he is also one of the greatest inventor in the world. So he was the inventor of DC, direct current. Okay, so back then during 1800, all houses, industries, they use DC because there was no AC yet. Okay, but the problem with DC is that they needed a very thick cable, because the formula. I'm not sure if you still remember this formula. V times I, right? Power or R. Power equal to voltage times current, or equal to current squared times resistance. Right? So the problem with DC, the cable is very thick because require constant. In DC, DC means direct current. If I draw the graph, this is DC. Okay. Okay, this is DC. This is I. This is time. So the current is constant every time. It's remain the same. Okay. So they needed thick cable, and the distance, the range cannot be far away, maybe 1 to 2 miles from the source, from the generator of DC. Okay. In Malaysia, maybe the generator is from the TNB, TNB power generator. Okay, and then came Nikola Tesla, where he found AC, alternating current. So if I show you the, I think we have here the, yeah. I'll just go through this one then before. This is the, okay, this is the circuit theory, electrical unit, Ohm's law, Kirchhoff law. I assume that you have learned all this. Why AC is required, whereas we already have DC. DC cannot be transmitted as economically as AC transmission system because DC require very thick cable. Okay, so cannot go very far. Okay, because the constant of current is remain constant at every time. But for AC, this is AC for example, this is I, this is T. So the graph will be like this. Can be sinusoidal or should be like this. Okay. They keep, the point is the value of I keep changing over time. Keep changing over time. So maximum, minimum, even zero here. The minimum, then zero, maximum, zero, minimum, zero. Okay. They want AC. AC can be stepped up and down using transformer. Nowadays, many electrical appliances are using AC system. Okay, now my question, for example. What about your battery charger? Your handphone battery charger. Is it DC or AC?
DC.
See, sir.
DC.
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 Okay, DC. Why is it not using AC? Why DC? Anyone? Why not using AC? Oh, question from Jaya Balan. Group member can be from different class or must be in the same. The same class, the same, what is it? The same section. Because in the system, we must be in the same section. So we problem that if you are joining another session. Okay, so phone charger is DC. Why is it? Because the distance. The cable is not will not take too long cable, so in only maybe 1 meter. 1 meter even maybe, right? So it doesn't matter using DC. The problem will happen if the cable gets longer and longer, okay? Because the longer the cable for DC, the longer the cable, the bigger the loss. The bigger the loss, because cable consists of, they have resistance, right? And the I value is constant. As for AC, the I value is keep changing. Okay. Yeah. What else? Let me see. Okay, this one. Most alternating systems operate on sinusoidal basis. Okay, can be sinusoidal, can be what is it just now? Rectangular shape, rectangular. Okay. Okay. This one. What is AC system? Okay, the magnitude of the voltage current vary in a repetitive manner. Repetitive. 1 cycle, 2 cycle, 3 cycle. Similar, right? This one is similar with this one, similar with this one. Repetitive manner. Okay. What is the characteristic of the AC current voltage? It flows first in one direction and then it in the other. Okay, like this one. Flows in one direction, yeah, positive. Okay, and then in the other, this one, the other, negative. If you draw AC, yeah, AC, this is the resistance. Okay, resistance. So first, for example, this one. So it goes this, the circle. But then during this moment, during this one, the negative one is goes the other way around. Right. Okay. This is what it means by flows first in one direction and then in the other. Okay. The cycle of variation is repeated exactly for each direction. Okay, question from Dada. So do I have to make video? No, no need. You don't need to make the video. As do the lab sheet, answer the question from lab sheet. Put down all the graph, the circuit. Okay. Okay, let's proceed. Okay, this one is how we generate AC voltage. If you see the one in the middle here, this one here, it's a coil. So by rotating the coil here inside the uniform magnetic field, this is magnetic field. Okay. At a constant speed. So the coil rotates between the magnetic field. Okay. So there's a load. This is the load, for example. This is output. This is the load. The load here, in here, the load. The load can be resistor, the lamp, and so on. Okay. So the load connected across the coil with the help of brushes. Okay, brushes. With the help of brushes and the slip ring. Okay, and the slip ring. So when the coil rotates in the anti-clockwise direction at a constant angular velocity, so the electromotive force EMF induced in the coil. Okay, so it will generate AC. voltage. Okay. So this is what installed in every TNB's plant, TNB's office, the plant actually, to generate AC. Of course, the size is very big then. There's a coil, there's a magnetic, uniform magnetic field. Okay, so by rotating the coil, it will give output of AC current. Okay, AC alternating current. So that one will transmit through the cable all the way to cover the whole Malaysia, for Malaysia. So can you imagine, for example, from where's the, I forget. I went to this power plant, I think in Perak or something, and then they have to distribute in almost the peninsula area. So you can imagine the distance, right? The distance. It's almost not possible. It's not possible, okay, if they use DC, direct current. Okay. So this is another technique to generate AC. First is tidal. What is tidal? In Indonesia, we call it pasang surut. Pasang surut, where the sea is have a high, very high level, and then very low one. Okay, so the difference, we use the difference there. We utilize the difference. In the picture there, you can see the high water mark, right, and the low one. Okay, the low water mark. So the pressure is going to produce, and of course there's a turbine below. The pressure going to produce the AC by turning the coil. There's also geothermal. Call it in Indonesia panas bumi, ya? Panas bumi. So we use the difference between the hot heated water and the cold one. That one, the difference is energy. It's the energy, the source of the energy. That one we use to turn the coil. And there's also wind power, wind energy. Okay, simple. Wind, they are moving the propeller blades, right, in here. And also there's a gearbox here. Okay, we go down there. And hydro. All of this, we call it, you are maybe familiar, transducer. We call it transducer. This is a device that we convert one energy to electrical energy. Okay? We convert one energy to electrical energy. So, for example, battery. Battery is a device to convert chemical to electrical, right? Battery. Chemical to electrical. What else? Dynamo. You know dynamo, huh? Dynamo in the bike.
The bicycle.
Yeah, bicycle. So what energy? Convert to what? Convert from what energy to which energy? Dynamo.
Kinetic to light, if I'm not mistaken.
Correct. Kinetic. Because they are using rotation of a wheel, right? So kinetic to electrical, that is the light. Okay, we call it transducer. Okay, there are many. So that one is generation of AC. Yeah? Okay. This one basically the detail of coil that will generate AC. You can read this in detail in the textbooks, I believe. All of you have the textbooks. So this is the cycle that generate the AC. If I think this one. Okay, this is the cycle. Okay, this is cycle. If you see here, once it's rotate from here to here. Look at the rotation here from the coil. This one. Look at the shape. Rotate, I think 90 degree. Yes, 90 degree. Anti-clockwise, huh? To the left, 90 degree. Every 90 degree. 1, 90, 180, 270, 330. Okay. This is the 1 to 90, 90 to 180, 180 to 270, 270 to 380. This one. And keep repeating the cycle. Okay. Okay, yeah. This is also the detail. EMF is electromotive force. Okay. This is what they are looking at the position where it will give maximum and minimum voltage. Okay. This is the minimum position. This one and this one. Okay. This is the maximum. This is the maximum position. Minimum is this one. Minimum. Huh? This is maximum. Minimum is this one. 0. Okay. Okay. This is also still the. This is the magnetic field. NS means north. NS north south. This is the position. If you look at the position there, right? This is the maximum one. Maximum position here. This is 0 position. This is 0 position, and this is the minimum. This one. Okay. If you compare this one and this one, look, almost the same. The difference is the pole. The pole is upside down. The pole. Look at the pole, the edge of the coil there, and this one. The pole is different, although the arrow is similar. 。 Okay, this one. There is one formula that you have to understand here. Of induced EMF. This one AM, this one, yeah. From this one, AM is this one. This is AL. This is AM, AL. So to find AM, AL sine theta here. But the one that, okay, this one also important. Okay. This one. So induced EMF equal to 2 pi B. B is what? B, breadth width of the loop in meters, N number of coil, A, area, N, speed of rotation in round per second, and sine theta. Okay. Peak value, this is peak value. Peak value, basically in here, you just delete the sign. Maximum of sine value equal to 1, right? Maximum. So 1. You replace sine with 1, so you get this one. Peak value. Okay, let's see example. Coil of 160 turns is rotated at 1,500 RPM, turn per minute. A magnetic field having uniform density of 1.15 okay, T. The mean area per turn is 50 centimeters square. Calculate frequency, period, maximum value of induced EMF, value of induced EMF when the coil has rotated through 30 degrees from position of 0 EMF. Okay, frequency, the given parameter is this one, this is frequency. But look at the unit, RPM. Frequency, the unit of frequency is Hertz. Hertz is 1/second, right? So you need to convert 100,500 RPM to RPS, round per second. So divide by 60, you get this one. Okay. Period is basically T equal to 1/f. 1/f, so 0.04 second. Maximum value of induced, you use this one. Use this one, maximum. Okay. Okay. Pi 2, pi is 3.14, B is 0. Okay, B is uniform density. N, number of coil. A, area 50. Don't forget the unit. This one is centimeter square. Convert to meter square. Okay. And N, just now. That's the frequency. Okay. And here, N is where is it? Here. Speed rotation in RPS. Okay. Equal to frequency. So you get this one. Okay. D, the value of induced EMF when the coil has rotated through 30 degrees from the position of 0 EMF. So E, small e. use the formula, this one. So basically, this one is this one, right? Equal to this one. So you just basically times this one with sine 30. Sine 30 is 0.5, so you have this one. Okay. Any question for the example? No. So if now we proceed with okay, this one. This is pole. Machine can have 2 or more pairs of pole. If a C generator has P pair of pole and if its speed is n revolution or rotation per second, then frequency is number of cycle per second times number of revolution per second, P times n. Okay, pair. Okay, so F P times n. Okay, just now here, F in here, if you see here, where's the, okay, here, 25 hertz. Okay, 25 hertz. So n is 25. Pole is one, right? Only one pole, one pair of pole. But if you see 6 pole of magnet, so you times 6 here. Depends on question. Here's the pole here. Here. This is one pole. Where's the other one? Okay, one pole. So usually one pole, but if question asking for more than one pole, so frequency just time the n times the pole. Okay. Okay, now last one. Let's go to waveform terms and definition. So I believe some of you are familiar. So period, time taken to complete one cycle. This is one cycle. So how many seconds in here? How much? For example, this one is 5. So 5 seconds means the period is 5 seconds. Okay. Peak value, maximum value. This one. Peak value. Peak to peak. Peak to peak. Sorry, my mistake. Sorry. Some mistake here. Some mistake. We draw this one. Oh, this one is better. We use this one. Because if we use this one, we have to draw. Okay. So in here, this is peak voltage, peak value. Okay. In here is this one, peak voltage. peak to peak is from maximum to minimum. This one, peak to peak. Frequency, number of cycles that occur in 1 second. So basically frequency is 1 over T, right? 1 over T. Amplitude, distance from its average to its peak. So basically this is the amplitude here. Average is this one usually. So depends on amplitude. Okay, it's changing. Okay, let's see example. Okay, for this one, period 10 milliseconds. Look at only one cycle. Huh? This is one cycle. Yeah. So this one is 10 milliseconds. Peak value. Peak value. This one peak value. So 10 volt. Peak to peak. So usually 2 times peak value. So 20. Frequency. Frequency basically is 1 over T. T is just now is 10 millisecond. So convert to second. So 100 hertz. Amplitude similar to peak value. Okay, 10 volt. So the second one, period. Be careful. Huh? Check this one. 10 millisecond. Peak value 5. Peak to peak 5 times 2, 10. Frequency 1 over T, 1 over 10 millisecond, right? So 100 hertz. Amplitude 5. Amplitude similar to maximum value. Okay, try this one. The answer. This is usually what you will find in the oscilloscope. So one division vertical axis, one division equal to 5 volt. For horizontal, one division equal to 10 millivolt. So what is the period? What is the peak value, peak to peak value, and frequency? I need the answer in either in volt or in second. The period, of course, in second. Peak value, of course, in volt. Frequency, of course, in hertz. So give me the answer. Type the answer there. Okay, let's see. Period 60 millisecond. Period is 1 second. Huh? How many seconds? So you have here 1, 2, 3, 4, 5, 6. So 6 times horizontal axis is 6 times 10. So correct. 60 millisecond. Huh? So it's correct then. 60 millisecond. 6 times 10. Peak, 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 peak value. 1, 2, 3, 4, 5. So 5 division times 5. So 25 fold. Correct. So peak to peak, basically just times 2. 25 times 2, so it's 50. Frequency, so 1 over T, 1 over 60 millisecond. So don't forget, convert to wait, there's a question. Example 1. Which one? Peak 5 volt. So about which one? Huh? This is correct. 5 volt, right? 5 volt. Oh, ini. Okay. Peak value. Yeah. Peak value is then, oh, this one, peak value. Okay, peak to peak here. Peak to peak, this is, yeah. Peak to peak, this one is 10. Yes, this is wrong then, good. Okay, good. Peak to peak is 10, right? 10. So this is 10. Then peak value is 5 then. Good. Okay, so sometimes even the textbooks can be wrong, eh? You know, make mistake. I want to ask how you search frequency and amplitude value. Frequency basically 1 over T. You get the T, so frequency 1 over T. Amplitude is equal to peak value. Okay, frequency just now. Wow, who answered that one? Okay. 1 over 60 milli. Convert to second. So 1000 plus 60. So 100 divided by 6. 100 divided by 6 is 8 Am I correct? 100 divided by 6.
Yeah. 16.67.
Correct. So 16.67 hertz. Okay. Okay. Any problem? This one? See, yeah. So this is what you're going to see a lot in oscilloscope because there will be diffusion there. There will be boxes. So one boxes represent a value for how many voltage or how many second for diffusion. Okay. I think that will be all for today. We'll proceed this one next week. Yeah. Any question so far? We'll finish this one next week. Don't forget your. Yes.
For the lab, we can straight away proceed. Is it?
With what?
No. The lab we can do it straight away or
Yeah.
finish.
I have upload the lab sheet. You can start doing it. The due date will be Friday next week, 5 p.m.
Okay, sir.
Okay. Lab 1, 5 p.m. So I will give, no need to do a record video. Just do what exactly the lab sheet, the question, the instruction, put all the circuit, answer the question. So I will give you a mark based on that. Okay. Another questions? So if you have no questions, I'll see you next week then on Friday. If you have anything to ask, just ask. You can ask Huang and let her ask me if regarding the lab or anything about the subject. If you want to ask in the group, this will be okay, but maybe it will take time for me to answer. Okay, guys. Thank you. I'll see you next week then.
Right, thank you,
Bye.
sir.
Thank you,
Alright,
sir.
thank you, sir.
Yeah.